Everyone, welcome to Abhi online classes. Today we'll discuss some more problems on absolute convergence and conditionally convergence of a series in infinite series chapter. First we see, examine the convergence and absolute convergence of the series sigma n is equal to 1 to infinity minus 1 whole power n plus 1 into n by n square plus 1. Obviously this is an alternating series. Take this alternating series given alternating series sigma n is equal to 1 to infinity minus 1 whole power n plus 1 into n by n square plus 1. This is equal to sigma n is equal to 1 to infinity minus 1 whole power n plus 1 into un. Here un equal to n by n square plus 1. This is positive for all n. Now we find out un plus 1. n plus 1 by n plus 1 whole square plus 1. This is equal to n plus 1 by n square plus 2 into n into 1 2n plus 1 square is 1 plus 1 2. Now we will find out this series is in this series each term is monotonically decreasing or not. Each term is numerically less than its preceding term. That is one of the conditions of Liveness test. So we will see by subtracting un from un plus 1. Now this is equal to n plus 1 by n square plus 2n plus 2 minus n by n square plus 1. Taking LCM, n square plus 2n plus 2 into n square plus 1. n plus 1 into n square plus 1 minus n into n square plus 2n plus 2. Now this is equal to n into n square n cube plus n into 1 n plus 1 into n square plus 1 n square plus 1 minus n cube minus 2n square plus into minus minus 2n by n square plus 2n plus 2 into n square plus 1. Cancel n cube. Now this is equal to minus 2n square plus n square is minus n square minus 2n plus n minus n plus 1 by n square plus 2n plus 2 into n square plus 1. So this is negative. This gives negative for all n. Therefore un plus 1 minus un is less than 0 for all n, which implies un plus 1 is less than un for all n. That means each term is numerically less than its preceding term. One condition of Liveness test is satisfied. Next we see the second condition of Liveness test, that is limit n tends to infinity un. Whether it gives 0 or not we see. Limit n tends to infinity. In this problem un is n by n square plus 1. Limit n tends to infinity n by, we take n square common, 1 plus 1 by n square. Cancel n. We write it as limit n tends to infinity 1 by n by 1 plus 1 by n square. N tends to infinity means 1 by n tends to 0. Therefore this is and this also 0. 0 by 1 plus 0. 0 by 1 is 0. Therefore limit n tends to infinity un equal to 0. This is the second condition of Liveness test. Previously we had seen each term is numerically less than its preceding term, and now limit n tends to infinity un is equal to 0. Both the conditions of Liveness test are satisfied. Therefore, by Liveness test, the given alternating series is convergent. Therefore, the given series is convergent. Now we test whether this series is absolutely convergent or not. Given sigma minus 1 whole power n plus 1 into n by n square plus 1. This is sigma un. We have considered this series as sigma un. Now we take modulus. Sigma modulus of un is equal to sigma. By making all the negative terms as a positive, it becomes n by n square plus 1. Now we call this new series as sigma vn. Therefore, vn is equal to n by n square plus 1. n by, we take n square common, 1 plus 1 by n square. Now this is equal to 1 by cancelling n into 1 plus 1 by n square. Therefore, this is vn. Now we choose another nth term, wn. We choose wn as 1 by n. Now, by dividing, vn by wn is equal to 1 by n into 1 plus 1 by n square by 1 by n. Cancel 1 by n. Now apply limit n tends to infinity. Limit n tends to infinity, vn by wn is equal to limit n tends to infinity 1 by 1 plus 1 by n square. As n tends to infinity, 1 by n tends to 0. Therefore, this gives 1 by 1 plus 0. It is equal to 1, which is a finite and a non-zero. Therefore, by limit comparison test, if wn is convergent, vn also converges. Suppose if wn is divergent, vn also diverges. Therefore, we will see whether it converges or diverges. Therefore, sigma wn is equal to sigma 1 by n. This is an auxiliary series. Therefore, by p-test, this is a divergent series. This is a divergent series since p is equal to 1. So therefore, since p is equal to 1, this is a divergent series. If this is a divergent series, by limit comparison test, sigma vn also diverges. Sigma vn is nothing but sigma mod un also diverges. If sigma mod un diverges, then the given alternating series is not absolutely convergent. That means it is conditionally convergent, or you can call it as semi-convergent. Therefore, the given alternating series is conditionally convergent. We will see one more problem. Examine the conditionally convergence of the series sigma minus 1 whole power n into root n square plus 1 minus n. We have to examine whether it is conditionally convergent or not. Let us see. The given alternating series sigma minus 1 whole power n into un. Sigma minus 1 whole power n into root of n square plus 1 minus n. Here un is equal to root of n square plus 1 minus n. Now we rationalize this. Root of n square plus 1 minus n into root of n square plus 1 plus n by root of n square plus 1 plus n. Now this is equal to a minus b into a plus b, a square minus b square by root of n square plus 1 plus n. Square and root cancel. N square plus 1 minus n square by root of n square plus 1 plus n. Cancel n square. Now this is equal to 1 by root of n square plus 1 plus n. This is un. Obviously this is a positive for all n. Now we find un plus 1 by replacing n by n plus 1. 1 by root of n plus 1 whole square plus 1 plus n plus 1. Clearly, as the denominator is increasing, un plus 1 is decreasing. So therefore, this un plus 1 is less than un. Comparing these two, this denominator and this denominator, when we observe, here the denominator of un plus 1 is greater. So obviously this un plus 1 is less than un for all n. Therefore each term is numerically less than its preceding term. The following first condition of Liveness test is satisfied. Now we'll see second condition of Liveness test. Limit n tends to infinity un equal to limit n tends to infinity 1 by root of n square plus 1 plus n. Limit n tends to infinity 1 by root, we take n square as common, 1 plus 1 by n square plus n. Limit n tends to infinity 1 by root of n square is n, root of 1 plus 1 by n square plus n. Limit n tends to infinity 1 by, take n common, root of 1 plus 1 by n square plus 1. Limit n tends to infinity means 1 by n tends to 0. Limit 1 by n tends to 0. We write down this as 1 by n by root of 1 plus 1 by n square plus 1. Now this is 1 by n tends to 0. Therefore this is also 0. 0 by root of 1 plus 0 plus 1. That means 0 by 2 gives 0. Therefore, limit n tends to infinity un is 0. This is the second condition of Liveness test. Therefore, first condition is each term is numerically less than its preceding term. Second term is limit of un is 0. Therefore, both the conditions of Liveness test are satisfied. Therefore, by Liveness test, sigma un is a convergent series. This alternating series is a convergent series. Our target is to find out whether this series is conditionally convergent or not. Now we'll see by taking modulus. Sigma modulus of un equal to sigma minus 1 whole power n into root of n square plus 1 minus n modulus. On applying the modulus, all the negative terms become positive. So sigma root of n square plus 1 minus n. Previously we have seen on rationalizing this, we will get 1 by root of n square plus 1 plus n. Now we consider this series as sigma Vn. Therefore, Vn is equal to 1 by root n square plus 1 plus n. We take n square common. 1 plus 1 by n square plus n. 1 by root of n square is n into root of 1 plus 1 by n square. N common. I have already cancelled square and root and taken n as common. This is Vn. Choose. Now we have to select another nth term. Choose Wn as 1 by n. Suppose if this is a divergent series, this series sigma Vn also diverges. Suppose if sigma Wn is convergent, sigma Vn also converges by limit comparison test. But we have to check whether divide Vn by Wn and it gives finite quantity or not, we'll see. Therefore, Vn by Wn equal to 1 by n into root 1 plus 1 by n square plus 1 by Wn is 1 by n. Cancel. Therefore, Vn by Wn is equal to 1 by root of 1 plus 1 by n square plus 1. Apply limit n tends to infinity. Limit n tends to infinity, Vn by Wn is equal to limit n tends to infinity 1 by root 1 plus 1 by n square plus 1. N tends to infinity means 1 by n tends to 0. Therefore, this is equal to 1 by root 1 plus 1, that is 1 by 2. That is a not equal to 0. This is a finite and non-zero quantity. Therefore, by limit comparison test, first we prepare sigma Wn. Sigma Wn is equal to sigma 1 by n by p-test. This is a divergent series. So since this is a divergent series, by limit comparison test, sigma Vn also a divergent series. Therefore, limit n tends to infinity, Vn by Wn gives a finite and non-zero quantity. Therefore, by limit comparison test, sigma Vn also a divergent series. Since sigma Wn is a divergent series. Sigma Vn is nothing but sigma mod Un. Therefore, sigma mod Un also diverges. In this problem, we have already seen previously, sigma Un is a convergent series. Now we have seen sigma mod Un is a divergent series. Sigma Un is convergent, sigma mod Un is divergent. Therefore, sigma Un is conditionally convergent. Or you can call it as semi-convergent or non-absolutely convergent. Therefore, the given series is conditionally convergent. These two problems are the essay problems for B.sc students. Hope you understood this class. Thank you.